You know, there's a huge global conflict happening right now, but it's not being fought on any battlefield you'd recognize. It's an invisible war, a fight for 17 critical metals that are hiding inside pretty much all the technology that powers our world, from the phone in your hand to the most advanced military hardware on the planet.
So let me ask you this. What in the world connects a cutting-edge fighter jet, a super sleek electric car, and the device you're probably watching this on right now? The answer isn't what you might think, like silicon or steel. Nope, it's a group of really obscure but totally essential materials called rare earth elements.
So let's dive into the world's secret ingredient. And right off the bat, you need to know that the name rare earths is kind of misleading. They aren't actually rare at all, but as you're about to see, they are absolutely essential. Okay, so what are we really talking about here? REEs are a group of 17 different metallic elements. And here's the twist, despite the name, they're actually more common in the Earth's crust than gold or silver. The real challenge, the thing that makes them so valuable, is that they're incredibly difficult and expensive to separate from each other and refine into a pure, usable form. That's the real bottleneck.
So why does all of our most advanced tech need these things so badly? Well, a great way to think about rare earths is like they're the essential vitamins for modern industry. You only need a tiny amount, but without them, these huge technological leaps just wouldn't be possible.
Let's take the Green Revolution, for example. You've got elements like neodymium and praseodymium. These are used to create magnets that are unbelievably powerful, but also super lightweight. And these magnets, they're basically the beating heart of the motors in electric vehicles and the generators inside those giant wind turbines.
And what about the brains of our digital world? The whole AI boom is built on top of incredibly advanced semiconductors. Well, to make those chips, you need an element called cerium. It's used in these special polishing powders to create surfaces that are perfectly smooth, totally defect-free, which is an absolute must for high-precision chip making. Bottom line, no cerium, no cutting-edge AI.
And this is where it gets into a whole other level of seriousness: national security. Our most advanced defense systems are completely dependent on rare earths. They're in the guidance systems, the radar, the sonar, and even stealth coatings. Get this, a single F-35 fighter jet has over 900 pounds of these materials inside it. And a Virginia-class submarine? It needs over 9,000 pounds.
Now check this out. This chart really ties it all together. Just look at that massive slice for permanent magnets. We're talking nearly half of all global demand. This is the common thread that connects everything. The same type of high-strength magnet that's in a Tesla motor is also what's needed for a Tomahawk missile's guidance system. And that convergence is what turns a simple supply chain problem into a massive national security dilemma.
So this brings us right to the core of the conflict: China's incredible dominance in this space. And the key thing to wrap your head around is that the real power isn't about who has the most mines. It's all about who controls the processing facilities, the factories.
So if we just look at who's digging the raw stuff out of the ground, China controls about 70%. I mean, that's a huge majority for sure, but it's not a total monopoly. You've got other countries like the US and Australia that have some pretty big mining operations. But remember, this is just step one.
This is the number that should really grab your attention. Over 90%. That is China's share of the global refining and processing market. See, it's not about who can mine the ore, it's about who can turn that ore into the usable, high-tech elements. This is the chokehold.
So how on earth did this happen? Well, it's really a two-part story. First, China spent years achieving total technical mastery over the super complex chemistry needed for separation. And second, for decades, they were willing to absorb the massive environmental costs of this really toxic process. That let them undercut all their competitors and basically drive Western companies completely out of the business.
Okay, so all of that sets the stage for what's happening right now. We are deep in a geopolitical tit-for-tat, a strategic battle where both the US and China are basically weaponizing their biggest advantages. And here's a quick look at how it all played out. First, the US blocked China's access to advanced semiconductor technology. China's response was fast and sharp. They didn't just restrict the export of the metals themselves, no, they went a step further. They restricted the technology and intellectual property needed to process them. That was a direct shot, basically trying to stop the West from ever building its own supply chain. The US then fired back with a threat of a massive 100% tariff on all Chinese imports.
And that threat, it creates this huge, weird paradox. The goal of a 100% tariff
is to force companies to find non-Chinese alternatives, right? To push for independence. But the immediate effect? It just doubles the costs of these critical materials for American manufacturers. It's basically a massive tax on the very industries it's supposed to be protecting, all because a real, viable alternative supply chain, well, it just doesn't exist yet.
And this table here shows you exactly who's in the line of fire. The defense sector, which relies on these really specific rare earth alloys, well, it's facing an extreme vulnerability. We're talking about production of F-35s potentially grinding to a halt. And at the same time, the EV and tech sectors, everyone from Tesla to NVIDIA, they're facing a high risk, which threatens both the green energy transition and the AI revolution. So, as you can imagine, this whole crisis has kicked off a frantic global race for resilience. The challenge is just enormous. It's about building an entire, incredibly complex supply chain pretty much from scratch, and doing it all under intense geopolitical pressure.
And there are three really crucial lessons that are coming out of all this. First, geopolitics is now in the driver's seat, not simple market economics. Being resilient is now worth paying a premium for. Second, the smart money isn't just going into digging new mines. It's going into building those complex, midstream processing plants. And third, these projects are just so expensive and so risky that they have almost no chance of succeeding without long-term, guaranteed support from the government.
So, who's actually stepping up to take on this challenge? Well, there are a few key players you should know about. You've got Lynas Rare Earths, based in Australia, which is currently the only company outside of China that's producing separated rare earths at a large scale. Then in the US, there's MP Materials, which is working hand in hand with the Department of Defense to rebuild a domestic supply chain. These aren't just regular companies, they are strategic, policy-driven investments.
And this is the timeline we're all up against. Even if you had unlimited money to throw at the problem, experts say it'll take a minimum of 3 to 5 years to build a truly viable, independent supply chain. That is a long, long window of serious vulnerability. So let's just boil it all down. The battle for these 17 elements is really a battle for who's going to lead in the foundational technologies of the 21st century. We're talking artificial intelligence, national defense, and green energy. This is not a fight over territory, it's a fight over the actual technological building blocks of our future.
Which of course leaves us with a really fundamental question. Securing these supply chains is going to mean accepting higher costs for basically everything, from our cars to our phones. So what price are we, as consumers and as nations, truly willing to pay for the materials that are going to build our future?